This demonstration is designed to show off SolidFire's guaranteed quality of service or guaranteed performance and the benefits that it has associated with a managed service provider. So right here we have the SolidFire user interface, and this particular cluster is running a multi-tenant type workload with various different customers running on top of it, some of which are running databases, applications, various different development type instances, and also virtual machines and VDI running at the bottom. So the challenge here is on this environment, performance is very, very inconsistent. So we have our database here that's running at an inconsistent level of performance, and we also have an application that is also running at an inconsistent level of performance because each one of these instances running on the same multi-tenant SAN can in effect influence the performance characteristics of other members on that same system. And the only reason you could do this on a SolidFire system is because we've set this min, max, and burst settings to the widest possible settings so that it can simulate what it would look like on that traditional SAN. Now once we set these settings with this script, I'm going to create 4 performance billable levels running all on the same system. 1 performance billable level for the database, 1 for the application, 1 for the development, and also 1 for the virtual machines down here. And as you can see with the left, the script is automatically setting them. So once I refresh, you can see that it's set these performance levels to each one of the various different applications, instances, and offerings on the same system. 1 for the database, 1 for the application, 1 for the development, and 1 down here for the virtual machine. Now, once I scroll over to the other page, you can see that these performance characteristics immediately take effect. In the case of the database right here, he's going to run through that brief burst cycle at up to 5,000 IOPS. The application is then going to settle at a more consistent 1,000 IOPS that we had set them to. And then from here, the database, what becomes the most important piece is that with this ability to set and provision the performance levels, it can also, since the IOPS level is correlated to the latency levels, as we increase the IOPS level, you can proportionately see the latency go down from previously what was an inconsistent right around 10 milliseconds of latency to what is now a much more consistent 1.2 milliseconds worth of latency. And similar idea over here for our application. But each one of these settings, not only could we set them the first time, but we can also change them dynamically on the fly. So what I'm going to do is on this first volume right here, I'm going to change the min, max, and burst settings on it to 5,000, 8,000, and 12,000 respectively. So once I refresh, you can see that they've been increased from 5,000, 8,000, and 12,000 IOPS respectively. And you can see immediately through the UI here, we see an increased level of performance. It's jumping up to right around 8,000 IOPS now. And then also proportionately, we see a decreased amount of latency as we raise those QoS settings accordingly. What is very important to note is because it's a provisioning performance type of a thing, very similar to what a hypervisor would do when you can provision virtual CPUs and virtual gigs of RAM, is it doesn't affect the performance characteristics of other volumes on the system. So this guy, we increased his performance, yet you can see our application, once he's been set, remains dead flat irrespective of the other volumes on the system. So let's increase his performance again. And now we've increased into 8,000, 12,000, and 15,000 IOPS respectively. And then we can see that increase accordingly. And then once this refreshes, you'll see the jump up in performance as well. And the reason why this becomes so imperative from a managed service provider perspective is twofold. The first is it virtually eliminates the number of performance-related tickets associated with a service provider. So that leads back into a significant operational expense decrease, which in turn leads to more revenue and more profits associated, and of course much happier customers. The second major benefit of doing this is then there are no longer the performance SLA breaches that are typically associated with, albeit a managed service or infrastructure as a service type of an instance, and these SLA breaches can become very costly, of course, depending upon the particular application and the particular use case.